Number systems. In your earlier classes, you have studied about number line and how to represent various types of numbers on it. Let us do a quick recap of those numbers. First numbers which you came across were natural numbers. As we know, we use 1, 2, 3 and so on when we begin counting. So these numbers are called counting numbers or natural numbers. It is represented by the symbol n. This is the number line for natural numbers. It starts from 1 and goes to infinity in one direction. In the collection of natural numbers, when we include 0, then it is called as whole numbers. Whole numbers, it is represented by the symbol W. This is the number line for whole numbers. It starts from 0 and goes to infinity in one direction. In the collection of whole numbers, when we include negative numbers as well, then it is called integers. So integers consist of 0, positive numbers and negative numbers. This is the number line for integers. It goes to infinity in both the directions. It is represented by the symbol Z. Why Z? Because it has come from the German word zählen. That means to count. Rational numbers. This is the number line for rational number. It consists of 0, positive numbers and negative numbers. It goes to infinity in both the directions. Then what is the difference between the number line for integers and that of a rational numbers? If I ask you, how many integers are there between 0 and 1 or between 0 and minus 1? You can clearly see that there are no integers between them. But in the case of rational number line, you can see between 0 and 1, I have marked 1 by 2. And between 0 and minus 1, I have marked minus 1 by 2. Does that mean there is only one rational number between 0 and 1 or between 0 and minus 1? I'll come back to this question later. But you can clearly see what is the difference between the number line of integers and that of a rational numbers. Rational numbers, it is represented by the symbol Q. Rational has come from the word ratio and Q has come from the word quotient. Let us quickly recall the definition of a rational number. A number R is called a rational number if it can be written in the form of P by Q, where P and Q are integers and Q is not equal to 0. Why Q cannot be equal to 0? Because if you put Q equal to 0 here, then P by Q is not defined. All these numbers, natural numbers, whole numbers and integers are all rational numbers. Why? Because you can write all these numbers in the form of P by Q, where P and Q are integers and Q is not equal to 0. Let us understand this with the help of one example. Let us take one integer, say minus 36. So I can rewrite this as minus 36 upon 1. So here your P is minus 36 and Q is 1. And you can clearly see here that denominator is not equal to 0. So I have rewritten minus 36 as minus 36 upon 1, which is P by Q form. So minus 36 is a rational number. Similarly, you can prove for natural numbers and whole numbers. Equivalent rational numbers. You can obtain equivalent rational numbers by multiplying or dividing both numerator and denominator by the same number except 0. For example, 1 by 2. If I multiply here both numerator and denominator by 2, then I get 2 by 4. If I multiply here both numerator and denominator by 10, then I get 10 by 20. If I multiply both numerator and denominator by 25, then I get 25 by 50. So all these numbers 2 by 4, 10 by 20 and 25 by 50 are all equivalent rational numbers for 1 by 2. If you are asked to represent equivalent rational numbers on number line, make sure that P and Q, they don't have any other common factor other than 1. That means P and Q are co-primes. So all these equivalent rational numbers and the number, they will represent the same point on the number line. Question, is 0 a rational number? Can you write it in the form of P by Q, where P and Q are integers and Q is not equal to 0. So in the first part of the question, it is being asked, is 0 a rational number? For any given number to be a rational number, it should be represented in the form of P by Q, where P and Q are integers and Q is not equal to 0. So can we write 0 in the form of P by Q? Yes, you can write 0 as 0 by 1. So what is the value of P here? Here P is 0 and Q is 1. So 0 and 1 are integers here. So you can clearly see P and Q are integers, and here q is equal to 1. So here q is not equal to 0. So it fits into the definition of a rational number. You have represented 0 in the form of p by q, where p and q are integers. Here p is 0 and q is 1. And q is not equal to 0. So it satisfies the definition of a rational number. So it is 0 is a rational number. So you can write down, so 0 is a rational number. Second part of the question is already answered because you have written this 0 in the form of p by q, where p and q are integers and q is not equal to 0. Now let us take the second question. State whether the following statements are true or false. Give reasons for your answers. So here first part is every natural number is a whole number. The answer is true because whole number is a collection of all natural numbers and 0. So every natural number is a whole number. Answer is true. Second part, every integer is a whole number. Answer is false. All the negative integers are not whole numbers. For example, -2, -3 and so on. So every integer is a whole number. The answer is false. Every rational number is a whole number. If you say any negative rational number or any fraction, that is not a whole number. For example, -1 by 2, 4 by 6, all these are rational numbers, but it is not a whole number. So answer is false. Find 5 rational numbers between 1 and 2. So you have to find out 5 rational numbers between 1 and 2. For that, we are going to use arithmetic mean concept. What is arithmetic mean concept? Sum of all observation divided by total number of observation. So when you use this, you get exactly the number which lie between all the observations. So here we have got only 2 observations. So let us add these 2 numbers, 1 plus 2 and divided by 2. This is sum of observation divided by number of observation, which we have 2. So 2 plus 1 is 3, 3 by 2. So we got one number between 1 and 2, that is 3 by 2. So this 3 by 2 lie exactly between 1 and 2. What is the value of 3 by 2? 1.5. And you know that 1.5 lie exactly between 1 and 2. Now let us take 1 and 3 by 2. So 1 I can write it as 2 by 2 plus 3 by 2. I am going to find out the number which lie exactly between 1 and 3 by 2. So I'll add these 2 numbers and then I will divide it by 2. So here 5 by 2 divided by 2 gives you 5 by 4. So as of now you got 2 numbers between 1 and 2. One is 3 by 2 and other one is 5 by 4. So you got here 1, 5 by 4, 3 by 2 and 2. So you can see you have got 2 numbers now. Let us add these 2 numbers and divide it by 2. So we will get the number which lie exactly between these 2 numbers. So 5 by 4 I am going to write down as it is. 3 by 2 I am going to write it as 6 by 4 divided by 2. So what do you get here? 6 plus 5 is 11. 11 by 4 divided by 2 gives you 11 by 8. So you got 3 numbers between 1 and 2. That is 3 by 2, 5 by 4 and 11 by 8. So you got 1 here, 5 by 4. Between these 2 numbers we have got it 11 by 8. So I am writing it here. And then we have 3 by 2 and we have 2. Now let us take 1 and 5 by 4. Between these 2 numbers, let us find out the number which lie exactly between these 2 numbers. So here 1 I can write it as 4 by 4 and this other number is 5 by 4. So we are adding these 2 numbers divided by 2. So here what do you get? 9 by 4 divided by 2 gives you 9 by 8. So you got 4 numbers now. So you got here 1, then after that 9 by 8. This is the first number now. 5 by 4, 11 by 8, 3 by 2 and 2. So you have got 4 numbers between 1 and 2. Now let us find out the number between 3 by 2 and 2. So 3 by 2 I am going to write down as it is, and 2 I will write down as 4 by 2. So this is 3 by 2 plus 4 by 2 divided by 2. So 3 plus 4 is 7. 7 by 2 divided by 2 gives you 7 by 4. So we have got 5 numbers between 1 and 2. Which are the 5 numbers? It is 9 by 8, 5 by 4, 11 by 8, 3 by 2 and 7 by 4. Like this, we can keep on finding out the numbers between two given rational numbers. So what we can conclude here, that there are infinite rational numbers between two rational numbers. Let us see one more method using which you will be able to find out the required number of rational numbers between two given rational numbers in one step. So here the required number is 5 rational numbers. You have to find out between 1 and 2. So how are we going to do it? So here it is 5. So you add 1 to that. So what do you get? 5 plus 1, 6. So this 6 we are going to multiply in numerator and denominator. So let us write down 1 as 1 by 1. So we will multiply here both in numerator and denominator by 6. So what do you get here? 6 by 6. So 1 is rewritten as 6 by 6. Similarly, 2, you can write it as 2 by 1. Here also we will multiply both numerator and denominator by 6. So what do you get here? In numerator you get 12, in denominator you get 6. So 2 you have rewritten as 12 by 6. So let us write down the 5 rational numbers between 1 and 2. What are those 5 rational numbers? Greater than 6 by 6 is, we have 7 by 6, then we have 8 by 6, then we have 9 by 6, then 10 by 6, then 11 by 6. So these are the 5 rational numbers between 1 and 2. So you can see this method is quicker than the previous method, and it is easy and simple to solve. Now let us take one more question here. Find 3 rational numbers between 1 by 5 and 1 by 3. So here you can see the denominators are different. So first you need to make the denominators same. So 1 by 5, what is the LCM for 5 and 3? It is 50. So 1 by 5, I am going to multiply here both numerator and denominator by 3 because LCM is 50. So what do you get here? 3 by 50. And 1 by 3, I am going to multiply both numerator and denominator by 5 because LCM is 15. So what do you get here? 5 by 50. So you can write down only one rational number between 3 by 15 and 5 by 15, that is 4 by 15. But we want how many? 3 rational numbers. So I have told you, you have to find out 3 rational numbers. So you add plus 1 to that. So 3 plus 1, that is 4. So with this method, you can get the sufficient number of rational numbers between two given rational number in one step. So 3 by 15, I am going to multiply both numerator and denominator by 4. So what do you get here? 3 4s are 12, 15 4s are 60. Here 5 by 15, I am going to multiply both numerator and denominator by 4. So what do you get here? 20 by 60. So you have sufficient numbers in between. So what are the rational numbers? 3 rational numbers between 1 by 5 and 1 by 3. They are, you can write down any 3. So I am writing 13 by 60, 14 by 60 and 15 by 60. There are some extra rational numbers here, but you can leave it because it just says 3 rational numbers. So you can write down these 3 rational numbers. Let us now discuss what are irrational numbers. The definition is very simple. Numbers which are not rational numbers are called irrational numbers. Let us quickly recall the definition of rational numbers. So rational numbers are the numbers which can be written in the form of P upon Q, where P and Q are integers and Q is not equal to 0. So all the numbers which satisfies this definition, they are called rational numbers, otherwise they are irrational numbers. Let us write down some examples of irrational numbers. For example, root 2, root 3, root 5, root 7 and so on. The list is infinite. We have discussed in the previous video that between two given numbers, there are infinite rational numbers. Similarly, between two given numbers, there are infinite irrational numbers. The collection of rational numbers and irrational numbers is called as real numbers. It is denoted by capital letter R. Every real number has got unique representation on the number line, or we can say that every point on the number line represents a unique real number. That is why we say the number line as real number line. You already know how to represent a rational number on the number line. In case if you have forgotten, you can refer my video whose link I have given in the description box below. Let us now see how to locate an irrational number on the number line with the help of this question. So here locate root 2 on the number line. Root 2 is an irrational number. You have to locate root 2 on the number line. The procedure is very simple. For this we need a square whose side is 1 unit. So if this is 1 unit, this also is 1 unit. You can clearly see here that this angle is 90 degrees because every angle in a square is 90 degrees. So here triangle OAB is a right angle triangle. So we can apply Pythagoras theorem and find out OB. So as per the Pythagoras theorem, we have OB square is equal to OA square plus AB square. So OB square is equal to OA is how much? 1. So this is 1 square. AB is also 1. So this is 1 square. So this is 1 plus 1 is 2. So you got OB square as 2. So you have to take square root on both the sides. So this side you will get OB and here you will have root 2. So you got how much is the length of root 2. What we will do here is we are going to place the square on the number line. So the number line is already drawn here and I have already placed the square here. This O is going to overlap with 0 and A is going to overlap with 1 because this is a square whose side is 1 unit and this length 0 to 1 is also 1 unit. So you have placed the square here and this OB is root 2. So what we are going to do is we are going to take our compasses and we'll put the compass needle here at point O and measure this length OB and we will make an arc on the number line. So this point over here represents root 2 on the number line. So here we have seen how to locate root 2. What about other irrational numbers? For example, root 3, root 5, root 7 or any irrational number in that case. So for this, what we have to do to locate irrational numbers, say root n, first you have to locate root n minus 1. So if you have to locate root 3, first you have to locate root 3 minus 1, that is root 2. So we have already located root 2. So here this is root 2. What we have done here, we have made a right angle triangle. So the same process we will repeat it and we will locate root 3. So this length is root 2. Here at point B, we will construct 90 degrees using protractor. So you can put your protractor like this and make an angle of 90 degrees. Let us do it. So let us make 90 degrees now. And this length has to be 1 unit. So this is 90 degrees here and this length is 1 unit. So this, if I mark this point as say S, then OS is root 3. Let us understand how this OS is root 3. This OS is root 3. So here again a right angle triangle is formed. OBS is a right angle triangle. And we are going to apply the Pythagoras theorem again to find out how much is OS. So OS square is equal to OB square plus SB square. So OS square is equal to OB square plus SB square. And here OB is root 2. So OB square means root 2 square. SB is 1. So this is 1 square. To take the square of square root of 2, you will get 2 and 1 square is 1. So you got OS square as 3. So now you have to take square root on both the sides. So when you take square root on both the sides, you will get OS and that is root 3. So this length is root 3. So again same thing you will do is, what you will do? You will keep the compass needle here at point O, pencil tip here, measure this length and make an arc on the number line. So that point will come somewhere here. So that is root 3. You can repeat the similar process to locate root 5, root 7 and so on. Let us now see the decimal expansion of real numbers. You know that real number is a collection of rational numbers and irrational numbers. You have a good friendship with rational numbers. So let us first take up the decimal expansion of rational numbers and then later on we will take up the decimal expansion of irrational numbers. To understand the decimal expansion of rational numbers, I have taken 3 rational numbers. Those are 10 by 3, 7 by 8 and 1 by 7. For all these 3 rational numbers, I have already done the division here. You need to observe these divisions carefully and tell me what do you notice. I am sure you all must have noticed that here the remainder is 0 and in these 2 cases the remainder is not 0. So what happens here? After a certain stage the remainder becomes 0 and here after a certain stage the remainder starts repeating. You can see the remainders are repeating. So that is our first point. What is our first point? That after a certain stage either the remainder becomes 0 or the remainder starts repeating. What else do you observe? See here, the remainders are all 1 and the divisor is 3. Here the remainders are 6, 4 and 0 and the divisor is 8. Here the remainders are 1, 2, 3, 4, 5 and 6 and the divisor is 7. So what do you notice? I am sure you must have noticed that the divisor is always greater than the remainder, or we can say that remainder is always less than the divisor. So this is our second point, that the remainder is always less than the divisor. Here you can see all the numbers which are lesser than 7 are there in the remainder. 1, 2, 3, 4, 5, 6. All these numbers are lesser than 7. So you can have maximum how many remainders when the divisor is 7? 6. Now let us take up the third point. What else do you observe? So when the remainder is not 0, you can see here the remainders are repeating, the quotient is also repeating. Similarly here, when the remainder is repeating, the set of blocks of numbers is going to repeat. You can see here, the quotient is repeating. You can see I have made a horizontal line here and I have made a horizontal line here. This is called bar. All the digits which are written under the bar, those set of digits, they will be repeating. Here all these numbers will be repeating because they are under the bar. Similarly here 3 will repeat because that is under the bar. Let us now conclude the decimal expansion of rational numbers. So you have 2 cases in the case of decimal expansion of rational number. The first case is when the remainder is 0. When the remainder becomes 0, the decimal expansion of the rational number terminates. So here in this case, the decimal expansion of 7 by 8 is 0.875, that is terminating. In the second case, when the remainder is not 0, you can see that the decimal expansion of the rational number is non-terminating, repeating. Here these set of numbers, they are not going to terminate, they will keep on repeating. Here also you can see this 3 is going to repeat. So in the second case, the decimal expansion of rational number is non-terminating, repeating, or you can use the word recurring. And you know that numbers which are not rational numbers are called irrational numbers. So what else do you think is left out in the decimal expansion? Only one case, where it is non-terminating and non-repeating. Moreover, if a number has a decimal expansion which is non-terminating, non-repeating, we can say that it is an irrational number. Similarly, we can say it for rational numbers as well. The numbers which have the decimal expansion as terminating or non-terminating, repeating, those numbers are called rational numbers. Let us understand with the help of few examples. Show that 3.142678 is a rational number. In other words, express 3.142678 in the form P by Q, where P and Q are integers and Q is not equal to 0. So you can clearly see this is a terminating decimal number. That means it is a rational number. So rational numbers, they are always expressed as P by Q form, where P and Q are integers and Q is not equal to 0. To do that, it is very simple. Let us do it. So it is 3.142678. We can rewrite this as 3142678. You can clearly see here the decimal point is after how many digits? 1, 2, 3, 4, 5, 6. So we will divide this number by 10 lakhs. That means it has got 6 zeros. So when you divide this number by 10 lakhs, you will get this number again. So you have already written now in P by Q form. Here this is integer, this is also an integer, and denominator is not equal to 0. So you have expressed this terminating decimal number as a rational number. Now let us take the next question. Show that 0.2353535 and so on is equal to 0.235 is under the bar. Can be expressed in the form P by Q, where P and Q are integers and Q is not equal to 0. So you can clearly see that this decimal expansion is non-terminating, repeating or recurring. So this is a decimal expansion of a rational number. So that is what they are asking here, to write down this in the P by Q form. Let us see how to do it. So what we are going to do here, we are going to assume this rational number to be x. So let x be equal to 0.235 bar. So here you can see 2 digits are under the bar. So we are going to multiply both the sides by 100 because here 2 digits are under the bar. If there is 1 digit, then you will multiply both the side by 10 if 1 digit is under the bar. So let us now multiply both the sides by 100 because there are 2 digits under the bar. So when you multiply both the sides by 100, you get here 100x. And when you multiply this by 100, the decimal point will shift here. So it is here as of now, so it will come here. So let us write it down. This is 23.535 bar. So when you multiply by 100, you will get this number. Now what we are going to do, we are going to subtract 1 from 2. We will subtract 1 from 2. So we will subtract the left hand side with left hand side and right hand side with right hand side. So 100x minus x, what will you get? 99x. So here when you subtract x from 100x, you get 99x. Now let us subtract this side. So I'll show you how to subtract. So from 23.535, 0.535 bar, you have to subtract 0.235 under the bar. 0.235, this is under the bar. So when you subtract it, this will be cancelled. So you will get 0 here. 5 minus 2 is 3, and here you will get 3, and here you will get 2. So what will you get? 23.3. So here you will get 23.3. Now we will bring 99 to the other side. So here you will get 23.3 upon 99. So this has to be integers. This is a decimal number. To convert into integer, I will multiply both numerator and denominator by 10. So when you multiply both numerator and denominator by 10, here you will get 233, and in denominator you will get 990. So the rational number is 233 upon 990. So if you divide this, you will get the same decimal expansion. Now let us discuss two famous irrational numbers, root 2 and pi. This is a decimal expansion of root 2. You can clearly see here, this is non-terminating, non-recurring. To find out the decimal expansion of root 2, you can use long division method. This is the decimal expansion of pi. This is also non-terminating, non-recurring. Now let us take this question. Find an irrational number between 1 by 7 and 2 by 7. So you have to find one irrational number between 1 by 7 and 2 by 7. There are infinite irrational numbers between two given numbers. Here you have to just write down 1. To do that, first write down this rational number in decimal form. Similarly, write down this number in decimal form. How will you do it? Just divide 1 by 7 here and divide 2 by 7 here, and you can get the decimal form. So you have to write down an irrational number between these two rational numbers. That means it should be greater than this and it should be smaller than this. So 0.2. You can clearly see that this is greater than this, but this looks like equal. But if I put here 6, then this is smaller than this. So you need an irrational number. That means it has to be non-terminating, non-repeating. So what I'll do is, I'll write down 1, 0, 2, 6, 1, 0, 0, 2, 6, 1, 0, 0, 0. So, and so on. So you can clearly see that this is non-terminating, non-repeating. Like this, you can write down as many irrational numbers you want. Operations on real numbers. You already know that rational numbers satisfy the commutative, associative, and distributive laws for addition and multiplication. You also know that rational numbers are closed under addition, subtraction, multiplication, and division except for 0. What does it mean? It means that whenever you add two rational numbers, subtract two rational numbers, multiply two rational numbers, or divide any two rational numbers except for 0, you will always get a rational number. Moreover, it turns out that irrational numbers also satisfy the commutative, associative, and distributive laws for addition and multiplication. But in the case of irrational numbers, it is not necessary that whenever you add, subtract, multiply, or divide any two irrational numbers, you will always get an irrational number. Sometimes you can get a rational number as well. Let us understand this with the help of few examples. Suppose you have an irrational number, say root 5. If you add minus root 5 to it, you will get 0. 0 is a rational number. Let me write down one more example. If you add 2 root 5 to 3 root 5, what will you get? 5 root 5. This is an irrational number. Let me write down some examples on subtraction. Suppose you have root 7 and you subtract root 7 from it, you will get 0. This is a rational number. Now let us take 4 root 6. From this, if I subtract 3 root 6, I will get root 6. This is an irrational number. Let me write down some examples on multiplication. Suppose you have root 3 and you multiply this to root 3, you will get 3. This is a rational number. Let me write down one more example. If you multiply 2 root 3 with root 2, you will get 2 root 6. This is an irrational number. Let me write down some more examples. This time I'll write down on division. Suppose you have root 8, and if you divide this by root 8, what do you get? 1. This is a rational number. But if I divide 2 root 3 by root 6, I will rewrite this as 2 root 3. Root 6 I will write as root 2 into root 3. So this will be cancelled. When you divide 2 by root 2, you will get root 2. This is an irrational number. So you must have noticed that whenever we are adding, subtracting, multiplying or dividing any two irrational numbers, sometimes we are getting a rational number and sometimes we are getting an irrational number. Let us now discuss what happens in that case whenever we add, subtract, multiply or divide a rational number with an irrational number. We are going to understand this with the help of this question. So here the question is saying, check whether 7 root 5, 7 upon root 5, root 2 plus 21, pi minus 2 are irrational numbers or not. So you need to check whether these numbers are irrational numbers or not. So let us first solve this one, 7 root 5. So 7 is a rational number. You are multiplying this with an irrational number, root 5. First we will write down root 5 in decimal form. To write down root 5 in decimal form, you have to use long division method, and using that you can easily write down root 5 in decimal form. Let us now multiply. So 7 into root 5 in decimal form is 2.236 and so on. So 7 into 6 is 42, carry over 4, 7 3 is 21, plus 4 is 25, carry over 2, 7 is 14, 14 plus 2 is 16, carry over 1, 7 is 14 and plus 1 is 15. So what do you get? 15.652 and so on. So this is non-terminating, non-recurring decimal number. That means it is an irrational number. Let us now solve this one. So 7 is a rational number. You are dividing with an irrational number, root 5. So we don't know how to divide a rational number by an irrational number, but we know how to divide by a rational number. So what we are going to do is we are going to convert the denominator into a rational number. To do that, we will multiply here both numerator and denominator by root 5. So in numerator you will have 7 root 5 and in denominator root 5 into root 5 gives you 5. This is a rational number. Now we can easily divide it. 7 root 5 value you have already calculated here in decimal form. Let us write it down. So that is 15.652 and so on. You are dividing it by 5. So when you divide, you will get 5 3s are 15, decimal point above the decimal point, 5 1s are 5. Then 5 3s are 15, 2 will not go, so 0, 5 4s are 20 and so on. So here also you get non-terminating, non-recurring decimal number. So here also you got an irrational number. Now let us solve this one, root 2 plus 21. So root 2 is an irrational number. We are adding 21 to this. To find out the decimal expansion of root 2, again you have to use long division method. So now let us write it down. Root 2 value is 1.4142 and so on. To this we have to add 21. So 21 plus 1 is 22 and after the decimal point you have 4142 and so on. So here also you got non-terminating, non-recurring decimal number. So this is also an irrational number. Now let us solve this one. Pi minus 2. Pi is an irrational number. From this we are subtracting 2, which is a rational number. The value of pi is 3.1415 and so on, minus 2. So 3 minus 2 is 1. And after the decimal point you have 1415 and so on. So here also you got an irrational number. You can clearly see this is non-terminating, non-recurring, so it is an irrational number. So now let us summarize that whenever you add or subtract a rational number from an irrational number, you will always get an irrational number. But whenever you multiply a rational number, it should be a non-zero rational number. Okay, so whenever you multiply or divide a non-zero rational number with an irrational number, the result is an irrational number. So let us now discuss some more questions based on the points which we discussed just now. So the first question is add 2 root 2 plus 5 root 3 and root 2 minus 3 root 3. So we have to add these two irrational numbers. So let us add them. So we have 2 root 2 plus 5 root 3. To this irrational number, we have to add root 2 minus 3 root 3. So what we are going to do? We are going to regroup them. So 2 root 2 and this root 2 I am writing it here plus 5 root 3 and then minus 3 root 3. So here you can take root 2 common. I am applying distributive property here. So inside the bracket you have 2 plus 1. Here I can take root 3 common. So inside the bracket you have 5 minus 3. So 2 plus 1 is 3. So you get 3 root 2. And here you get 2 root 3. So you got an irrational number. Now let us solve this one. Multiply 6 root 5 by 2 root 5. So here we are multiplying two irrational numbers. So 6 root 5, you have to multiply this with 2 root 5. So when you multiply 6 into 2 is 12 and root 5 into root 5, you will get 5. So 12 into 5 is 60. This is a rational number. Here you have multiplied two irrational numbers and you got a rational number here. Now let us take this question. Divide 8 root 15 by 2 root 3. So you have to divide 8 root 15 by 2 root 3. So you can cancel it out. I'll just rewrite it here first. So 8 root 15, I can write it as root 3 into root 5. And in denominator, you have 2 root 3. So you can cancel root 3, 2 and 8 you can cancel. You will have 4 here. So you got an irrational number, 4 root 5. So here you have divided an irrational number by an irrational number and the result is here an irrational number. Let us now discuss the operation of taking square root of real numbers. Quickly recall that if a is a natural number, then square root of a is equal to b, which means that b square is equal to a and here b is greater than 0. If you square on both the sides, what will you get? B square is equal to a. So you can clearly see here that a is a perfect square of b and b is square root of a. The same definition is extended for real numbers as well. So let a be a real number and here a is greater than 0. So square root of a is equal to b, which means that b square is equal to a and here also b is greater than 0. Earlier in this chapter, we have seen how to represent root n on the number line, where n is a positive integer. Let us now see how to represent root x geometrically, where x is a positive real number. We will understand this with the help of one example. So let us assume that x is equal to 3.5. So we will locate square root of 3.5 geometrically. To do that, on a given line, okay, at the end point, we will mark this point A. On the same line, at a distance of 3.5 units, we will mark this point B. And at a distance of 1 unit from B, we will mark this point C. So here, all these 3 points A, B and C lie on the same line. Now we will find out the midpoint of this line segment AC and name that point as O. So taking O as the center and OC as the radius, we will draw this semicircle. Now we will draw a line perpendicular to this line segment AC, passing through this point B and intersecting the semicircle at this point D. So here BD is square root of 3.5. So we will follow the same steps to locate root x geometrically. So let us start. On a given line, at the end point, we will mark a point A, and on the same given line, at a distance of x units, we will mark this point B. And from B, at a distance of 1 unit, we will mark this point C. Now we will find out the midpoint of this line segment AC, and we will name that point as O. Taking O as the center and OC as the radius, we will draw this semicircle. Now we will draw a line perpendicular to this line segment AC, passing through this point B and intersecting the semicircle at the point D. So here BD is root x. So how is that BD? We are saying that it is root x. Let us understand now. So you can see here this angle ABD. This angle is 90 degrees because we have made this line segment BD perpendicular to this line segment AC. So this angle over here is 90 degrees, and in a right angle triangle we can apply a Pythagoras theorem. So here this triangle OBD is a right angle triangle, and we can apply the Pythagoras theorem here. So using the Pythagoras theorem we can find out this BD. So to find out BD using Pythagoras theorem, we should know how much is OB and how much is OD. So you can see that OD and OC both are equal because they both are the radii of this semicircle. And how much is the diameter? X plus 1, and radius is half of the diameter. So let us now find out how much is OC or how much is OD. So these two are radius, so that will be half of the diameter. Diameter is X plus 1. Divided by 2 gives you the radius. So you got to know how much is OD. Now we have to find out how much is OB. That is simple. From OC, if I subtract this 1 unit, we will get this OB. Let us find out. So OB is equal to, from this OC, how much is OC? X plus 1 upon 2 is your OC. If I subtract 1 from this, we will get OB. So we can rewrite 1 as 2 by 2, right? So OB is equal to x plus 1 upon 2. This 1 I am writing as 2 by 2. So here in numerator you have x plus 1 minus 2. So plus 1 minus 2 gives you minus 1. So in numerator you have x minus 1 upon 2. So you got how much is OB. So we got these two now, OD and OB. Now let us find out BD using the Pythagoras theorem. So using the Pythagoras theorem, BD square is equal to OD square minus OB square. And how much is OD square? OD square is x plus 1 upon 2 whole square minus OB you got as x minus 1 upon 2 whole square. So here you can use two formulas. One formula is a plus b whole square. You can apply this and open it here. And here you can use a minus b whole square and solve it. Or you can use a square minus b square. I am going to use the second one, a square minus b square. Here a is x plus 1 upon 2 and b is x minus 1 upon 2. So a plus b, how much it will be? It is a is x plus 1 upon 2. This is a plus b. This is your b. So x minus 1 upon 2 into, now we will do a minus b. A is x plus 1 upon 2 minus b is x minus 1 upon 2. So here you have x upon 2 plus x upon 2. So that is x. And here 1 upon 2 and minus 1 upon 2. So both will be cancelled. So here you have x. And here x upon 2 minus x upon 2 will be cancelled. Here 1 upon 2 minus into minus is plus 1 upon 2. So 1 upon 2 plus 1 upon 2 will give you 1. So x into 1. So you got BD square as x. So if you take square root on both the side, you will get BD. So BD is equal to root x. So now you have understood why BD is square root of x. So this construction shows the visual and geometrical way of representing root x, where x is a positive real number. If you want to represent this root x on the number line, we will treat this BC line as a number line. So here we will take B as 0, C as 1 and so on. Now taking B as the center and BD as the radius, we will draw this arc. So it will intersect this number line at this point E, and this is your root x. Let us now extend the idea of square roots to cube roots, fourth roots, fifth roots, or in general nth roots. Let us quickly recall the concept of square roots and cube roots. So if I ask you what is cube root of 8? So you know that that is a positive number and that is 2. I can write the same thing as 2 cube is equal to 8. When you multiply 2 3 times, you will get 8. Now if I ask you what is the fifth root of 243? So if you are not able to calculate it mentally, then you have to do the prime factorization of 243 using the prime factorization method. And when you do that, you will find the factors of 243 is 3 is multiplied 5 times. So this is fourth time and this is the fifth time. So you have to find out the fifth root of 243. That means you have to make group of 5. So here you can see that 3 is in a group of 5. So when you take the fifth root of this, you will get 3. Or we can write the same thing as 3 raised to the power 5 is equal to 243. So using these examples, let us generalize that if a is a real number which is greater than 0 and n is a positive integer, then nth root of a is equal to b if b raised to power n is equal to a. Are you able to relate it? See here, b raised to power n is equal to a. So here 3 raised to power 5 is equal to 243. Or you can say that fifth root of 243 is 3. So that is written over here. Nth root of a is equal to b. Please note that this symbol which is used here, here and here is called the radical sign. Let us now see some identities related to square roots. Here a and b are positive real numbers. So the first identity is square root of AB is equal to square root of A into square root of B. Let us understand this. So here square root of A, I can rewrite it as A raised power 1 by 2. Cube root of A, I can rewrite it as A raised power 1 by 3. Or the nth root of A, I can rewrite it as A raised power 1 by n. So here we are using one law of exponent. Which is that law? AB whole raised power n is equal to A raised power n into B raised power n. Let us replace n with 1 by 2. So here AB whole raised power 1 by 2 is equal to A raised power 1 by 2 into B raised power 1 by 2. Now I am going to use this concept here and rewrite like this. So here I can rewrite it as square root of AB is equal to square root of A into square root of B. So I hope you must have understood how this has come. Now let us take the second identity. Here also we are going to use some law of exponent. So let us see what it is first. So square root of A by B is equal to square root of A upon square root of B. So let us see using which law of exponent we have got this. So you know that A by B whole raised power n is equal to a raised power n upon b raised power n. And let us replace n by 1 by 2. So here you have a by b whole raised power 1 by 2 is equal to a raised power 1 by 2 upon b raised power 1 by 2. So using this logic again here we can rewrite this as square root of a by b is equal to square root of a upon square root of b. So is it clear now, this identity? Now let us move on to the third identity. Here inside the brackets you have square root of a plus square root of b. This is multiplied to square root of a minus square root of b, which is equal to a minus b. Here also we have used one identity which you have learned in your previous classes. Let me write it down. So that identity is x minus y into x plus y, that is equal to x square minus y square. So instead of x you have root a and instead of y you have root b. So I'll just replace x with root a and y with root b. So using this identity we have to take the square of square root of a minus square root of b. So I can rewrite this as using this one, a raised power 1 by 2 whole raised power 2 minus b raised power 1 by 2 whole raised power 2. So again we are going to use one law, power of a power, a raised power m whole raised power n is equal to a raised power m into n. So you just multiply the powers. So here what you will get, a raised power 1 by 2 into 2, so you can cancel this, minus b raised power 1 by 2 into 2, you can cancel this, what do you get? A minus b, just written over here. Now let us take the next identity. Here inside the brackets you have a plus square root of b, which is multiplied to a minus square root of b. This is also inside the brackets. So using this same identity, you will get it as a square minus b. You have to take the square of a, so you will get a square minus sign and square root of b is b. Now let us move on to the next identity. So here inside the brackets you have square root of a plus square root of b. This is multiplied to square root of c plus square root of d. So here distributive property is used. How? When you multiply square root of a to square root of c, you get square root of ac. Then you will multiply square root of a to square root of d, you will get square root of ad. Then square root of b into square root of c, you will get square root of bc. Then you will multiply square root of b to square root of d, you will get square root of bd. So this is how you will get it using distributive property. Let us move on to the last identity. So here you have inside the brackets square root of a plus square root of b. You have to take the whole square. So here also you can use one identity which you have used in your earlier classes, that is a plus b whole square, that is equal to a square plus 2ab plus b square. So let us do the same thing here. So you have to take the square of square root of a, so you will get a twice of square root of a into square root of b, so that will give you twice of square root of ab, and then you have to take the square of square root of b, so you will get b. Let us now take one question based on these identities. So the question is, simplify the following expressions. What do you mean by this word simplify? Simplify means you have to solve this and write down your answer as the sum of a rational number and an irrational number. So let us solve it now. So here inside the brackets you have 5 plus root 7, which is multiplied to 2 plus root 5. So you are going to use which identity? You are going to use this identity, that is distributive property you have to apply here. So 5 into 2 gives you 10, then plus 5 into root 5, you will get 5 root 5. Then you will multiply root 7 to 2, so you will get 2 root 7. Then you have to multiply root 7 to root 5, so you will get square root of 35 because 7 into 5 is 35. So you can see that you have written the answer as the sum of a rational number and irrational number is here. Now let us take the next question. So here inside the brackets you have 5 plus root 5, which is multiplied to 5 minus root 5. So this is similar to which identity? It is similar to this identity here. So using that, you have to take the square of 5. That is 5 square minus, what is written over here? Minus b. So that is 5 here. So 5 square is 25 minus 5. So that is 20. Now let us take the next question. You have to take the square of root 3 plus root 7. That is whole square. Whole square of root 3 plus root 7. So that means you have to use this identity. So it is a plus twice of square root of ab plus b. So here your a is 3 and b is 7. So here a is 3 plus 2 root a is 3, b is 7 plus b. So here b is 7. So 7 plus 3 is 10 and then you can simplify this to square root of 7 into 3 is 21. Now let us take the next question. So inside the brackets you have square root of 11 minus square root of 7. This is multiplied to square root of 11 plus square root of 7. So this is exactly same as this identity. So here a is 11 and b is 7. So using that we have a minus b. So what do you have here? 11 minus 7 and that is equal to 4. Now let us take the next question. Rationalize the denominator of 5 upon root 3 minus root 5. So what do you mean by this word rationalize? It means you have to write down the denominator as a rational number. You can see the denominator is an irrational number. You have to make this denominator as a rational number. So what we are going to do? Let me just write it down. So here in the numerator we have 5 and in the denominator root 3 minus root 5. So to make the denominator as a rational number, if you multiply this by root 3 plus root 5, we'll get a rational number. You can see here, you are multiplying here instead of a, it is 3. Instead of b, it is 5. So if you multiply this with this, you will get a rational number. So that is what we are going to do here. So I'm going to multiply here with root 3 plus root 5. So same number I have to multiply in the denominator as well. Root 3 plus root 5. So you are multiplying this. So in the numerator you have 5 into root 3 plus 5 root 5. And in the denominator you have 3 minus 5 because this is a minus b. So here what will you get? 5 root 3 plus 5 root 5 upon 3 minus 5 is minus 2. Let us now discuss laws of exponents for real numbers. Do you remember the laws of exponents which you have studied in your earlier classes? Let us write them down. So the first one is a raised power m into a raised power n is equal to a raised power m plus n. Here a is a non-zero integer and m and n are whole numbers. You remember that a is called the base and m and n are exponents. So here we are multiplying the two numbers which have the same base. So what will happen to the exponents? We will add them. Next we have a raised power m divided by a raised power n. Here we are dividing two numbers which have same base. So what will happen to the exponents? We will subtract them. So you have a raised power m minus n. Here m is greater than n. Next we have a raised power m into b raised power m. Here the two numbers, they have different base. Here the base is a and here the base is b. So we can rewrite it as AB whole raised to power m. Then we have a raised power m divided by b raised power m. So here the two numbers, they have the different base. So we can rewrite this as a by b whole raised power m. Then we have a raised power m whole raised power n. So what will happen to the powers? We will multiply them. So here you have a raised power m into n. If I ask you what is a raised power 0, you know that it is 1. But do you know why any number raised power 0 is 1? Let me explain you with the help of this law. So here we have a raised power m upon a raised power n. That is equal to a raised power m minus n. So you want a raised power 0. So to get that, here if I replace n by m, then we will have m minus m, and that will give you 0. So let us write it down. So a raised power m, we will just replace n by m. So that is equal to a raised power m minus m. So here m minus m is 0. So this side you got a raised power 0. This side, in numerator you have a raised power m, and in denominator also you have a raised power m. You have the same numbers in numerator and denominator. So what will you get? 1. Or you can rewrite this as a raised power 0 is 1. Using this same law, we can get this. 1 upon a raised power n is equal to a raised power minus n. Let me explain you. So here we have a raised power m upon a raised power n is equal to a raised power m minus n. So you want 1 here. So you know that a raised power 0 is 1. Let us put it here. So we have a raised power 0 in the numerator and we have a raised power n. So we have just written 0 instead of m. So we will write down here 0. So a raised power 0 minus n. A raised power 0 is 1 upon a raised power n, and 0 minus n is minus n. So we got this. So later on we have studied that we can extend this idea to negative exponents as well. So the numbers having negative exponents obey all these laws. Let me explain you with the help of few examples. Suppose you have 7 raised to power 5 into 7 raised to power minus 15. So here the exponent is negative and the bases are same. So using this law, we will add the powers. So here you have 7 raised to power 5 plus of minus 15. So when you solve this, you will get 7 raised to power minus 10. Let me give you one more example. You have 8 raised to the power 6 divided by 8 raised to the power minus 5. So here you can see that the exponent is negative. So using this law, we can solve it. So that is 8 raised to power 6 minus of minus 5. So minus into minus is plus, and 6 plus 5 is 11. So you have 8 raised to the power 11. So now suppose you have to solve these questions. You can clearly see that in all these questions, exponents are all rational numbers. So there is a need to extend the law which you have studied till now. So now we have base as a positive real number and exponents are rational numbers. Let us now state the law. So if there is a real number which is greater than 0 and p and q are rational numbers, then we have these following laws. Using these laws, let us solve these questions. So the first one is 2 raised to power 2 by 3 into 2 raised to power 1 by 3. So here the bases are same. So you have to add the exponents. So 2 raised to power 2 by 3 plus 1 by 3. So when you add them, what will you get? 2 raised to power 3 by 3 and 3 by 3 is 1. So we have 2. Now let us solve the second question. So the second question is 3 raised to power 1 by 5 whole raised to power 4. So to solve this, we will use this law. We will multiply the powers. So this is 3 raised to power 1 by 5 into 4. So what will you get? 3 raised to power 4 by 5. Now let us solve the third question. The third question is 7 raised to power 1 by 5 upon 7 raised to power 1 by 3. So we are going to use this law and solve it. So when we will take this number in the numerator, we will have 7 raised to power 1 by 5 minus 1 by 3. So when you solve this, you will get 7 raised to power 3 by 15. Here the LCM of 5 and 3 is 15. So we can rewrite 1 by 5 as 3 by 15 minus, and 1 by 3 we can write it as 5 by 15. So 3 by 15 minus 5 by 15, you will get it as 7 raised to power minus 2 by 15. Now let us solve the fourth question. So the fourth question is 13 raised to power 1 by 5 into 17 raised to power 1 by 5. So here the bases are different, powers are same. So we will use this law. Here A is 13, B is 17 and P is 1 by 5. So using that, we can rewrite this as 13 into 17 whole raised to power 1 by 5. So when you multiply 13 into 17, you will get 221 and whole raised to power 1 by 5. Now suppose you have to solve this question 4 raised to power 3 by 2. So there are two ways to solve this. One way is 4 raised to power 1 by 2 whole raised to power 3. How I have rewritten it like this? Using this law. A raised to power P whole raised to power Q is equal to A raised to power P into Q. So A raised to power P into Q is written over here, and like this we have rewritten over here. So you know that 4 raised to power 1 by 2 is nothing but square root of 4, and that is 2. So inside the brackets we have 2. So now you have 2 cube, and 2 cube is 8. So this is one way of solving. Another way to solve is 4 raised to power 3 by 2. We can rewrite this as 4 cube whole raised to power 1 by 2. So using the same law, we can rewrite it like this. So 4 cube is 64 and raised to power 1 by 2. So what is this? We can rewrite like this. This is square root of 64. And square root of 64 is 8. So whether you solve it like this or you solve it like this, both way you got the same answer. So using this, we have this following definition. So here A is a real number which is greater than 0, and M and N are integers and they have no common factor other than 1, and N is also greater than 0. Then we have A raised to power M by N. We can rewrite this as nth root of A whole raised to power M, or we can rewrite this as nth root of A raised to power M. Are you able to understand this? Let me explain you. So nth root of A, what does it mean? It means that we can rewrite this as A raised to power 1 by N, and we are taking whole raised to power M. So this is whole raised to power M. So using this law, the powers will be multiplied. So what will you get? A raised to power M by N, which is this. Similarly, it is for this one as well. Let me explain you. This is nth root of A raised to power M. So we can rewrite this as A raised to power M whole raised to power, this is nth root. So we can rewrite this as 1 by N. Again using the same law, we have to multiply the exponents here. So what you will get? A raised to power M by N. Let's solve some questions on number systems. I have taken all these questions from Oswaal Books. So the first question is 1 upon root 2 is a oblique and dash number. So here we have got four options. A option is rational, B is irrational, C is fractional, and D is none of these. So you have to look out for the correct option here. So you know that the product or the quotient of a non-zero rational number with an irrational number is irrational number. So here we have 1 as a rational number, and in the denominator we have root 2, which is an irrational number. So as per the rule, you are dividing here a rational by an irrational. So the answer is an irrational number. The correct option is B. Now let us take the second question. So the second question is 5 raised to the power 6x is equal to 125 square. Then x is equal to dash. You need to find out the value of x here. So we are going to use this to find the value of x. So we have 5 raised to the power 6x is equal to 125 square. So let us make the base same and try to solve it. So 125 we can write it as 5 cube. So let us write it. So this is 5 cube whole raised to the power 2, and on this side we have 5 raised to the power 6x. So now we can multiply the exponents. So you will have 5 raised to the power 6, and here you have 5 raised to the power 6x. So you can see that there is an equality sign here. That means this number over here is equal to this number over here. And here the base is 5, and here also the base is 5. So these two numbers will be equal when their exponent is also same. So we can rewrite this as 6x is equal to 6. So x is equal to 1. So the correct option over here is C. Now let us take the third question. So we have value of 7 raised to the power 10 into 8 raised to the power 10 is dash. So here we are going to use this log. A raised to the power p into b raised to the power p. So what we will have? ab whole raised to the power p. So using this log, we can multiply 7 into 8. So 8 into 7 is 56 whole raised to the power 10. So the correct option is B. Now let us take the next question. State true or false. So every real number is represented by a unique point on the number line. Also, every point on the number line represents a unique real number. That is true. Every real number has got a unique representation on the number line. Or the same thing we can say it in other words, that every point on the number line represents a unique real number. So this is true. Let us now take the fifth question. Write the simplest form of a rational number 225 divided by 1250. So there are many ways to solve this. If you divide both numerator and denominator by highest common factor, you can write down the simplest form in one step. Or whatever common factor you can find out in both numerator and denominator, you can cancel them out. Or you can write down the prime factors of 225 and 1250, and then you can cancel the common factors. I am going to divide both numerator and denominator by 25. That is the highest common factor of these two numbers. So 225 divided by 1250. So here in numerator I am going to divide by 25. So I have to divide denominator also by 25. So what you will get? When you will divide 225 by 25, you will get 9. And when you divide 1250 by 25, you will get 25 5s are 125, and this one 0 is there. So this is 9 upon 50. Now let us take the last question. So here we have to represent 0.239 bar in the form p by q, where p and q are integers and q is not equal to 0. That means you have to write down this decimal expansion as a rational number. So let us assume that rational number is x. So we can equate them then. X is equal to 0.239 bar. So there are 3 digits under the bar. So we are going to multiply both the sides by 1000. So here you will have 1000x, and when you multiply this by 1000, you will get 239.239 will be under the bar. So now I am going to subtract first one from the second one. So 1000x minus x will give you 999x. And from this, when you will subtract this, the decimal part will be cancelled out. Only the whole part you will have. So you will have 239. So x is equal to 239 upon 999. So the rational number is 239 upon 999. So now let us take the 7th question. If a is equal to 3 and b is equal to 2, then find the value of a raised power b plus b raised power a. So here in this question, the values for a and b is given to you. You need to calculate the value of this expression. So for that, we will substitute the values of a and b here and find it out. Let us do it. So we have a raised power b plus b raised power a. So the value of a is 3 and b is 2. So we have 3 square here, plus b is 2 and a is 3. So we have 2 cube. So 3 square is 9 and 2 cube is 8. 9 plus 8 is 17. So the value of this expression is 17. Let us now take the 8th question. So is square root of 12 divided by square root of 3 a rational number or not? So you need to find out whether this is a rational number or not. You can see here in numerator you have square root of 12 and in the denominator you have square root of 3. So you are dividing an irrational number by an irrational number. So the answer can be a rational number or an irrational number. So let us solve it and find it out. So square root of 12 upon square root of 3. We can rewrite this as 12 raised to power 1 by 2. And similarly, we can write 3 square root of 3 as 3 raised to power 1 by 2. So using this law, we can solve it. A raised to power p upon b raised to power p is equal to, we can rewrite it like this, a by b whole raised to the power p. So here p, instead of p we have 1 by 2, and instead of a we have 12, and instead of b we have 3. So using this law, let us solve it. So what will you get? You will have it like this. 12 upon 3 whole raised to the power 1 by 2. And you can divide 12 by 3. So what you will get? 4. So inside the brackets you have 4. And this is raised to power 1 by 2. So you know that we can rewrite this as square root of 4. And that is 2. Now let us take the 9th question. Find 32 raised to power 1 by 5. So you need to find out the value of this. So 32 you can rewrite it as 2 raised to power 5. Do the prime factorization and find it out. So 32 raised to the power 1 by 5. So 32 can be expressed as 2 raised to power 5. This is whole raised to the power 1 by 5. So using this law we will solve. A raised to power p whole raised to power q is equal to a raised to power p into q. So you have to just multiply the exponents. So you have 2 raised to power 5 into raised to power 1 by 5. You can cancel it out. So you will have answer as 2. So now let us solve the 10th question. Find the product of 5 root 3. Inside the first bracket you have 3 plus root 3. Inside the second bracket you have 5 plus root 3. So you have to find the product of this. To do that we have to apply distributive law here to solve it. So let us do it. So we have 5 root 3. So now we will apply distributive law here. So 3 into 5 you will get 15. Then you will multiply 3 to root 3. You will get 3 root 3. Then you will multiply root 3 to 5. So you will get 5 root 3. And then you will multiply root 3 into root 3. So you will get 3. So 15 plus 3, you will get 18. So let us write it down. So you have 18. 3 root 3 plus 5 root 3, you will get 8 root 3. Let me explain you how we got this. We can apply distributive law here again to solve it. So you have 3 root 3 plus 5 root 3. So from these two you can take root 3 common. So inside the bracket you have 3 plus 5. So 5 plus 3 is 8. So what will you get? 8 root 3. Again you have to apply distributive law here to solve it. So you have to multiply 5 root 3 to 18. So what will you get? 90 root 3. Then you have to multiply 5 root 3 to 8 root 3. So 8 into 5, you will get 40. And root 3 into root 3, you will get it as 3. So here you have 90 root 3 and 40 into 3 is 120. So now you can leave your answer here. So the product of this is 90 root 3 plus 120. Now let us take question number 11. If 2 raised to power 3x into 4 raised to power x is equal to 8 raised to power 1 by 3 into 64 raised to power 1 by 6, then find the value of x. So you need to find out the value of x from here. So let us write it down. So you have 2 raised to power 3x into 4 raised to power x is equal to 8 raised to the power 1 by 3 into 64 raised to the power 1 by 6. So here 4, 8 and 64. We can express all these numbers with the base 2. Let us rewrite it. So 2 raised to power 3x instead of 4, we can rewrite it as 2 square. That is 4 raised to power x is equal to, instead of 8, we can rewrite it as 2 cube. This is raised to power 1 by 3. 64 is 8 into 8, right? And 8 is 2 cube. So 2 cube into 2 cube. What will you get? 2 raised to power 6. So into 2 raised to power 6 whole raised to power 1 by 6. Now let us simplify it further. So here the bases are same. So we will add the exponents. You can multiply these two numbers. So 2 into x will give you 2x. So you have 2 raised to power 3x here and you have 2 raised to power 2x. So when you add them, what will you get? 2 raised to power 5x. On this side, this 3 and this 3 will be cancelled. When you multiply the powers, similarly when you multiply the powers here, 6 and this 6 will be cancelled. So what will you have here? 2 into 2. So you can add it now, powers. Here the power is 1, here the power is 1 because the base is same. So you have 2 raised to power 2 here and here 2 raised to power 5x. So 2 raised to power 5x is equal to 2 square. So you can see that there is an equal to sign here. So here the base is same. Here the base is 2 and here also the base is 2. So this number is equal to this number and that will only happen when the exponents are also same. So we can write it as 5x is equal to 2. So x is equal to 2 by 5. Now let us solve the 12th question. If x plus root y is equal to 2 minus root 3 whole square, then find the values of x and y. So here in this question, this is given to you and you need to find out the values of x and y. So let us solve. So we have this. So let us use it. X plus root y is equal to 2 minus root 3 whole square. So we can solve this using this formula a minus b whole square. So this is equal to a square minus 2ab plus b square. So in place of a you have 2 and in place of b we have root 3. So using this formula, let us simplify this. So we have x plus root y is equal to 2 square is 4 minus 2, a is 2 and b is root 3 plus b square. That means root 3 whole square. So you will get 3. So 4 plus 3 gives you 7 and here you have minus 4 root 3. And this side you have x plus root y. So here x is a rational number and 7 is a rational number. Here root y is an irrational number and minus 4 root 3 is an irrational number. So let us equate them. So you have x is equal to 7. So you got the value of x and root y is equal to minus 4 root 3. So you have to calculate the value of y. So if we take squares on both the sides, we can get y. So let us square on both the sides. When you square it, what will you get? Y is equal to, if you take the square of this number, so then 4 square is 16 and minus into minus will become plus and root 3 whole square will give you 3. So 16 into 3, you will get 48. So you got the value of x and y. Now let us take the 13th question. What would be the denominator after rationalizing 7 upon 5 root 3 minus 5 root 2? So in this question, it is asked, what would be the denominator after you rationalize it? As of now, you can see the denominator is an irrational number. So you have to convert this irrational number into a rational number. So let us do that. So in the denominator we have 5 root 3 minus 5 root 2. So to rationalize this, I will use this formula square root of a minus square root of b. I am going to multiply this with square root of a plus square root of b. This square root of a plus square root of b, this is conjugate of this number. Here this remains the same. Here it is root a, here also it is root a. Here it is root b, here it is root b. Minus changes to plus. So this is conjugate of this number. So when you multiply this, so what will you get? A minus b. You take the square of root a. So you get a and we write down minus sign and then we take the square of square root of b and we get b. Same thing we will do for this one and we will rationalize it. So let us solve. So you have 5 root 3 minus 5 root 2. So we will multiply this with its conjugate. So we will write it 5 root 3 plus 5 root 2. So you will get a rational number. So we have to take the square of this number 5 root 3. So let us see. 5 root 3 you need to take the square. So 5 square is what? 25 and root 3 square is 3. So 25 into 3 you will get 75. Similarly, you have to take the square of this number as well. 5 root 2. When you take the square here, 5 square is 25 and root 2 whole square is 2. So 25 into 2 is 50. So when you square them, you get 75 and 50. Let us write it down. So you will get here 75 minus 50. So that is equal to 25. So the denominator is a rational number here and that is 25. So now let us take the 14th question. If 9 is power n into 3 square into 3 is power minus n by 2 whole is power minus 2 minus 27 raised power n divided by 3 raised power 3m into 2 cube is equal to 1 upon 27, prove that m minus n is equal to 1. So here this is given to you and you need to prove this. So we are going to use it to prove this one. So let us write it down. So we have 9 raised power n into 3 square into 3 raised power minus n by 2 whole raised power minus 2 minus 27 raised power n divided by 3 raised power 3m into 2 cube is equal to 1 upon 27. So here you can see that for all these numbers, they are written in exponential form. And for these numbers, the base is 3, and for this number, the base is 2. So let us write down 9 and 27 also in exponential form. So the exponential form for 9 is 3 square, and for 27 it is 3 cube. So this will solve our purpose. So let us write it down. So instead of 9, you can write it as 3 square. This is whole raised power n. So using this law, a raised power p whole raised power q, you can rewrite it as a raised power p into q. So you are multiplying the exponents. So what will you get here? 3 raised to the power 2n. So let us write it down. So here you will have 3 raised power 2n into 3 square. Similarly, for this one also we are going to use the same law. So we will multiply the exponents. So minus n by 2 into minus 2. So minus and minus will be cancelled, and you can cancel this 2 as well. So what will you get? N. So here you have into 3 raised to power n minus 27, you can write it as 3 cube. So this is whole raised to the power n. So using the same law, we will multiply the exponent. So what will you get? 3 raised to power 3n. So let us write it down. So here you have 3 raised to power 3n divided by 3 raised to power 3m into 2 cube is equal to 1 upon 3 cube. So here you can see that the bases are same. So we can add the powers. So 2n plus n will give you 3n. So here you have 3 raised to power 3n plus 2 minus 3 raised to power 3n divided by 3 raised to power 3m into 2 cube. This is equal to 1 upon 3 cube. So from these two numbers you can take 3 raised to power 3n common. So let us take it common. So here you have 3 raised to power 3n. So when you take 3 raised to power 3n common from here, what will be left out? 3 square. You can see that. When you take these two common, what is left out? 3 square. So here you have 3 square and here you have 1. So we have applied distributive property here to rewrite it like this. In the denominator you have 3 raised to power 3m into 2 cube. This is equal to 1 upon 3 cube. So 3 square is 9 minus 1. So what will you get? 8. And 8 you can rewrite it as 2 cube. So you can cancel this. So what you have now? 3 raised to power 3n in the numerator, and in the denominator you have 3 raised to power 3m. Here this side you have 1 in the numerator, and in the denominator you have 3 cube. So let us bring this one down. So we will use this law to solve. So a raised to power n is equal to 1 upon a raised to power minus n. So the exponent will become negative. So let us rewrite it. So on this side you have 1 in the numerator now because you are bringing this one down. So in the denominator you already have 3 raised to power 3m and into 3 raised to power minus 3n. This is equal to 1 upon 3 raised to power 3. So here the bases are same. So you can add the powers. So when you add the powers, what will you have? 3 raised to power 3m minus 3n is equal to 1 upon 3 cube. So here you can see that there is an equality sign, and here on both the sides the numerator is 1. So here also the denominator should be equal, then only this side will be equal to this side. And in the denominator you can see the base is same, that is 3. So for the denominator numbers to be same, exponent also should be same. So we can write it like this. 3m minus 3n is equal to 3. So you can take 3 common from here. So what will you get? M minus n is equal to 3. So you can cancel this 3 and this 3. So what will you have here? 1. So what will you get? M minus n is equal to 1. So that is what it is required. So hence proved. Let us now do question number 15. Assertion and reason based MCQs. Directions. In the following questions, a statement of assertion A is followed by a statement of reason R. Mark the correct choice as. So this is an assertion and reason based MCQ. There are two questions over here. This is the first one and this is the second one. The first statement is of assertion, which is followed by the statement of reason. There also the first statement is of assertion and the second one is reason R. After that, you have to choose the correct option from here. So let us start. The first question, assertion A, root 2 is an irrational number. Reason R, the sum of a rational number and an irrational number is an irrational number. So first step is to check whether this is true or false. Even for this, you have to check whether this is true or false. So let us check. Is root 2 an irrational number? Yes, this is correct. Second one, the sum of a rational number and an irrational number is an irrational number. This is also correct. Now the second step is you have to check whether this reason is the correct explanation for this statement or not. So here the reason given is the sum of a rational number and an irrational number is an irrational number. For what? Root 2 is an irrational number. So of course this is not the correct reason. The correct reason is root 2 is an irrational number because it is non-terminating, non-recurring. So this is true, but this is not the correct explanation of this statement. Now let us choose the correct option. So option A is both A and R are true, that is fine, and R is the correct explanation of A, that is not correct. So let us move on to the next option. B option is both A and R are true, but R is not the correct explanation of A. So the correct option is B because both are true and R is not the correct explanation of A. Let us now take the second question. Assertion A number 0.57 bar in the form of rational number P by Q is 29 upon 99. Reason R, decimal expansion of 29 upon 99 is non-terminating and recurring. So the first step is to check whether this is true or false. Similarly, you have to check for this one, whether this is true or false. So let us do that. So here the first statement is a number 0.57 bar in the form of rational number P by Q is 29 upon 99. So let us find out the rational number which represents 0.57 bar. So let us assume it to be x. So x is equal to 0.57 bar. Since there are two digits under the bar, we will multiply both the sides by 100. So here you have 100x and here you will get 57.57 bar. Now we will subtract the first one from the second one. So here 100x minus x, you will get 99x. And here the decimal part will be cancelled. So only 57 will be left. So x is equal to 57 upon 99. So the rational number for this decimal expansion 0.57 bar is 57 upon 99. And what is given over here? 29 upon 99. So this statement is false. Now let us check for the reason whether it is true or false. So the reason is decimal expansion of 29 upon 99 is non-terminating and recurring. So we have to see whether the decimal expansion of 29 upon 99 is non-terminating and recurring or not. So what you have to do? You have to divide 29 upon 99, and when you will divide it, you will get 0.29 bar. So you can clearly see that the decimal expansion of 29 upon 99 is non-terminating recurring. So this reason is true. This is one way to find out whether the decimal expansion of a rational number is non-terminating and recurring or not. There is one more method where you have to just see the denominator of the rational number. If the denominator of the rational number is 2, or you can express it as 2 raised power n, or if the denominator is 5, or it is any power of 5, like 5 square, 5 cube, and so on, or it is a combination of both, then the decimal expansion of that rational number will be terminating. Otherwise, it is non-terminating recurring. So let us see. For 99, you can express 99 as 3 into 3 into 11. When you multiply these numbers, you will get 99. All these are factors of 99. So you can clearly see that you cannot express it like this. So for this rational number, the decimal expansion will be non-terminating recurring. Now let us choose the correct option for the second question. So here A is false and R is true. So you can see here D option. A is false and R is true. So you have to put a tick mark for D option. Let us now discuss question number 16. Case-based questions. Attempt any 4 subparts from the given questions. Read the following text and answer the following questions on the basis of the same. To judge the preparation of class 9 students on the topic real numbers, a math teacher asked the following question. So here case-based questions are asked. A math teacher wants to check the preparation of class 9 students on the topic real number. So he wants to ask these following questions from them. But before that, they need to see the text given over here. So let us start and take the first question. Which of the following is an irrational number? So you need to check which number out of these is an irrational number. So you know the decimal form of an irrational number is non-terminating, non-recurring. And here in the options they have given you only the decimal forms. So let us check one by one. So here you can see the decimal form is terminating. So of course this is not the correct option. Here the decimal form is non-terminating recurring. So this is also not the correct option. Here it is 3.245, 245 and so on. So you can see that 245, 245 is repeating and it is not terminating as well. So which form is this? Non-terminating repeating. So this is also not there. Only D option is left out, but let us check. 3.245, 2245, 222 and so on. So you can clearly see that this is non-terminating, non-recurring. So this is an irrational number. You can put a tick mark for this D option. Let us now move on to the second question. What is the decimal form of 2 by 11? You need to find out the decimal form of 2 by 11. So for that, you need to divide 2 by 11. So it will go by 1. So you can see again the remainder is repeating. So the question will also repeat. So you will get 0.18 bar. So here B option is having 0.18 bar. So you can put tick mark for B option. Now let us discuss the third question. Decimal form of 2 by 11 is, you can clearly see that this is non-terminating repeating. So that option you will find it here in D. So non-terminating and recurring. So you can put a tick mark for D option. Let us now discuss question number 4. Write the P by Q form of 0.38 bar. So you need to write down the P by Q form of 0.38 bar. So let us assume that P by Q form of 0.38 bar is X. So we can equate them. So X is equal to 0.38 bar. Since there are 2 digits under the bar, we will multiply both the sides by 100. So this side you will get 38.38 38 bar. Now we will subtract the first one from the second one. So what we will get? Here you will get 99x and here you will get 38. So what is the value you got for x? 38 upon 99. So the P by Q form of 0.38 bar is 38 upon 99. And which is that option here? A option. So you can put a tick mark for A option. Now let us take the fifth question. In the fifth question, if P by Q form of 0.38 bar is m by n, then find the value of m plus n. So here P by Q form of 0.38 bar is m by n, and just now we have calculated the value of m by n. What is that? 38 upon 99. So here the value of m is 38 and the value of n is 99. So you can easily calculate the value of m plus n now. Just substitute the corresponding values. So in place of m, write down 38 and in place of n, write down 99. So when you will add them, what will you get? 137. So you will find that A option has got 137. So you can put a tick mark for A option. So you must have noticed that the questions are really good and would definitely help you to score good marks in your exams. So if you want to solve such challenging questions, click on the link given in the description box below and purchase it right away.